Analyzing infinite limits. When evaluating the limit of 1 over the quantity x minus 3 squared as x approaches 3, it's been helpful to look at the graph, locate any vertical asymptotes, and determine what the behavior of the function is. It's obvious from this graph that the equation of the vertical asymptote is x equals 3. And by examining the graph, we can also conclude that the limit of negative 1 over the quantity x minus 3 squared as x approaches 3 is equal to negative infinity. It seems that in the case when the denominator equals 0, but the numerator does not, as x approaches a certain number, we have to know what the graph looks like before we can calculate a limit. Actually, this is not always necessary. By looking at values really close, or also known as infinitesimally close, to the asymptotes, we can analyze the behavior of the function, whether it grows unbounded to positive or negative infinity. Let's try an example. Evaluate the limit of 5 minus x over the product of x minus 3 and x plus 1 as x approaches 3. First, let's recognize that x equals 3, if we actually substitute 3 into the function, we get a 0 in the denominator, mainly because 3 minus 3 would equal 0, and 0 times anything is 0. So we would have a 0 in the denominator. So let's consider approaching 3 from the left first. If we do that with, say, an x value of 2 and 9/10, we substitute in there and evaluate, we would get negative 5 and 38/100. Now let's use a value that's even closer to 3, such as 2 and 99/100. If we substitute that value in for all of the x's in our function, we end up getting negative 50 and 38/100. We can see a trend as we continue to get very close to an x value of 3. If we put in 2 and 999 thousandths into our function, we get a value of negative 500 and 38/100. So if we analyze these y values or function values, they grow unbounded towards negative infinity. Next, let's consider approaching 3 from the right. If we substitute a value fairly close to 3, such as 3 and 1/10, in for our x values, we end up getting 4 and 63/100. Now let's use a value that's even closer to 3, such as 3 and 1/100. We substitute that value in for x in our function, we get 49 and 63/100. We can see that a trend occurring here as we continue to get closer and closer to x equals 3. If we do 3 and 1/1000th, we get as the y value 490 and 63/100. So the function value grows unbounded towards positive infinity when approaching 3 from the right. So we found that the limit of 5 minus x divided by the product of x minus 3 and x plus 1 as x approaches 3 from the left is equal to negative infinity. And the limit of 5 minus x over the product of x minus 3 and x plus 1 as x approaches 3 from the right is equal to positive infinity. And since negative infinity and positive infinity do not match, the overall limit of 5 minus x divided by x minus 3 times x plus 1 as x approaches 3 does not exist. Now let's try this example. Evaluate the limit. The limit of the function 2 minus x over the quantity x minus 6 squared times x minus 4 as x approaches 6. First, recognize that x equals 6 is a 0 in the denominator. And since it cannot be canceled out with anything in the numerator, it's non-removable, meaning it is not a whole. Instead, it's going to be an asymptote. So as we're approaching the asymptote, we are going to look at the behavior of the function as x approaches 6. First, let's start by approaching from the left. So we'll use 5 and 9/10 as we substitute it in to the function. And when we do that, we end up getting negative 205 and 3/10. And then if the next number that we substitute in is 5 and 99/100, we end up getting negative 20,050, which is a much smaller number. So we can quickly see that as you get closer and closer to x equals 6 from the left, you're approaching negative infinity. Now let's consider approaching x equals 6 from the right. So we're going to pick a number that is close to 6, such as 6 and 1/10. And when we substitute that value in, we end up getting negative 195 and 2/10. And if we get closer to 6, say 6 and 1/100, we substitute that value in and evaluate, we get negative 19,950. And we can clearly see that the function values continue to grow unbounded towards negative infinity. Since we found that the limit of 2 minus x over x minus 6 squared times x minus 4 as x approaches 6 from the left is equal to negative infinity, and the limit of the same function as x approaches 6 from the right is also equal to negative infinity, we can say that the overall limit of our function 2 minus x divided by x minus 6 squared times x minus 4 as x approaches 6 is equal to negative infinity.